Hi, my name is Leo, and I'm an engineer at Takamori Robot. This is my robot Tanix. My goal at Takamori Robot is to work with the H.I.R.O platform as a test engineer. I'm trying to push it to its limits and suggest changes to the platform if it needs changes. Can your robot walk forward? Can your robot walk backward? Can your robot wave? Can your robot rotate counterclockwise? Can your robot rotate clockwise? Can your robot dance? Can your robot stretch side to side? Can your robot do push-ups? Can your robot do a cabbage patch? Can your robot face left? Can your robot face right? Can your robot charge forward? Can your robot shake? Can your robot fall down? Can your robot do a series of random commands? Can your robot play music? So what makes Tanix special? Tanix operates using what's called the H.I.R.O platform. It's a platform that contains all the code that Tanix uses to operate. The H.I.R.O platform consists of a series of different libraries that H.I.R.O uses to function. It includes emotes, exercises, several different motions, and different walk cycles, as well as new additions including a few songs, and the addition of an ultrasonic sensor that detects how far the robot is from something. It also includes a manual servo control mode as well, where you can type in a value and you can manually set the position of each individual servo motor on this robot. With H.I.R.O, you can learn 3D modeling, 3D printing, programming, electronics, wiring, circuit diagrams, embedded systems. A great reason why programming with H.I.R.O can be so easy compared to other robots and other embedded systems is that there are several built-in libraries that are already defined that the user doesn't have to worry about if they don't want to. They could just run the robot out of the box with pre-existing functions from those libraries, and they don't have to worry about programming. H.I.R.O is different from other robots in many ways. One of the big examples is that H.I.R.O has 4 legs, whereas other robots have wheels. Many robots with wheels are faster, but they're also harder to control and harder to stop. And it often takes people more experience in robotics to know how to control a robot that uses wheels. And using the H.I.R.O platform, I can control Tanix by just typing in a number on my computer and pressing enter. H.I.R.O having 4 legs gives it a very lifelike design and enables the robot to do many actions that humans can do that many other robots can't do, like waving, or dancing, or doing push-ups. And that's just to name a few. H.I.R.O is a very beginner-friendly robot, and there's many reasons for this. The first example is that out of the box, it's remarkably easy to assemble. All the parts you need are in the box, and the only tool you need to assemble H.I.R.O is a screwdriver. All of these parts, except for the breadboard, the wires, this microcontroller, the Raspberry Pi Pico, are all 3D printed. So everything snaps into place, and it can be assembled in 2 hours, compared to other robots, which can take days or weeks to assemble. You can personalize H.I.R.O in several ways. First of all, there is the plate on the front that you can attach a sticker on, which has a face. You can also choose which color of 3D printed materials you can have, so you can make the robot different colors as well. You can also choose different ways to wire the robot, depending on which pins on the Raspberry Pi Pico board are available. And biggest of all, you can customize the code that H.I.R.O runs on using Arduino IDE. Another benefit of the H.I.R.O platform is that the robot is very easy to program compared to other robots and other embedded systems. The robot runs on Arduino IDE, which is a very easy application to learn compared to other programming languages like C++ and Verilog. Unlike C++ and Verilog, Arduino takes a lot less time to compile the code and upload it to the robot. In fact, in Verilog, for example, it can take about 6 times as long to compile the code and upload it compared to Arduino and the H.I.R.O platform. H.I.R.O can also save users a lot of time with debugging and testing, because with H.I.R.O, it's very easy to see where mistakes are made in the code. And if a mistake is made, you can easily correct it and re-upload the code to H.I.R.O in less than a minute. For people looking to get into robotics, H.I.R.O can save a lot of money. Compared to other robots, like most battle bots, which use weapon motors, drive motors, speed controllers, and a lot of metal parts, H.I.R.O doesn't use any of those. You don't need any additional equipment to make H.I.R.O work. All the parts are already 3D printed, and assembling them doesn't take a lot of work either. You don't need to solder any of the wires onto the breadboard to make them connect to the Raspberry Pi Pico board, and the Arduino IDE is also a free program to use as well. So when you get a H.I.R.O robot, it comes in a box like this, and it contains everything you need to build a robot. It contains 3D printed shoulders and legs, a 3D printed cortex, 8 micro servo motors, a breadboard, a Raspberry Pi Pico board, lots of jumper cables that extend around the Raspberry Pi board and plug into the breadboard, an ultrasonic sensor here, piezoelectric buzzer right over here hidden behind the faceplate, and additional components as well, including resistors, LEDs, and an MPU as well. If any part of a H.I.R.O robot gets damaged, it's easy to fix, because all you need to do is detach any part of the 3D printed assembly, swap out the damaged part, and then put everything back in. And you don't need any tools to do that. And if something's wrong with the code, like I mentioned before, all you need to do is go in and change the code and then re-upload it, and it takes less than a minute to do so. And if something's wrong with the wiring, none of the wires are soldered, so you can simply remove a wire from the breadboard and put it somewhere else if the wiring is wrong. With my robot Tanix, I've learned about just how fun robotics can be. Programming was something that was hard for me to learn, and embedded systems was a hard subject for me to learn as well. Tanix, along with the H.I.R.O platform, has made that process incredibly easy. It runs off of an easy application to learn, with parts that are easy to assemble, and you can make a finished product that's satisfying to look at and interact with. I like learning with H.I.R.O a lot. I can push the robot to its limits. H.I.R.O encourages me to explore and learn as much as I can about every aspect of robotics. If I want to learn how to 3D model parts that I need, I can do that. If I want to learn how to program something that I need, I can do that. If I want to wire an additional component that doesn't come in the box, I can get it, and then I can wire that component to the robot. I specifically like Tanix a lot. There's no other robot that looks even close to this. There's no other robot that was assembled this way. I know that this robot's mine. One of the unique things about Tanix is that this robot can play music on its own. It uses this black cylindrical device called a piezoelectric buzzer, and it's programmed using the Arduino IDE like everything else, and uses built-in functions that are native to Arduino's libraries. Arduino's libraries include functions like tone, no tone, and delay. So you can manually choose what frequency you want the sound to be, the duration of the sound, and if you want silence, how long do you want the silence to be. And using this, you can play any song that you want. So right now I'm compiling a code that runs a song called Coming Up Close by the band Till Tuesday. And this song just loops infinitely because I put it in an infinite loop, so it can play it as many times as I want it to play. A unique feature that I added to Tanix is I gave it a manual control mode. So I can type in the code number 17, and then it'll give a message saying direct servo mode, and then I can type in which servo I want to control, and then an underscore followed by what degree to set the servo to. So for example, if I type in 1_90, it will set the right front leg to 90 degrees. Watch this. And it extends outward like that. If I want the left front leg to extend 180 degrees, then I will go 3_180, and it will do that. And if I want to exit the manual control mode and return to the normal program, I'll type in -1. And the robot will return to its default stance. For my future work as a test engineer, there are several projects that I want to do with Tanix. First of all, the H.I.R.O platform comes with an MPU, and I haven't even touched that device at all, and I have no idea what it's capable of doing with my robot Tanix. So it will be very interesting to see what that's capable of doing in the future. Another thing I want to do is I want to somehow move this ultrasonic sensor so that if H.I.R.O's on an elevated surface and it's about to fall, the sensor can detect that there's no ground in front of it and stop itself before it falls. Another thing that I'm certainly going to do with the robot is integrate the piezoelectric buzzer with the main program, so I can make H.I.R.O play different songs as it does different tasks. For example, I can play dance music when a dance command is selected. It's easy to learn robotics concepts using H.I.R.O, but at the end of the day, you still need to be curious You still need to have a growth mindset. You still need to want to learn. So you need to remember that robots are fun and that exploration is play.